Now, in a substance, particles are always moving. They're moving randomly, and this random motion is because of the kinetic energy that they possess. But all particles do not have the same kinetic energy. They have a range of kinetic energy. But when we talk about kinetic energy of particles, we talk about the average kinetic energy. So it's an average value of the individual kinetic energy of the particles. And this average kinetic energy is directly proportional to the absolute temperature. Absolute temperature, we're talking about temperature in Kelvin. So the temperature, absolute temperature of the substance is directly proportional to the average kinetic energy of the particles. Now we have what we call the Maxwell-Boltzmann distribution curve, and this curve is going to show the distribution of the molecules according to their kinetic energy. Concerning this curve, it's very important that you know the labeling of the axis. So the y-axis is the number of molecules or particles with the kinetic energy, with a certain amount of kinetic energy. And the x-axis is showing you the kinetic energy of the particles. Here you have the activation energy, and this is the minimum amount of energy that particles need in order for the reaction to take place. So over here you have the proportion of particles that have enough energy to react, and over here, the unshaded area, you have the proportion of particles in the sample that do not have enough energy to react. You have to be very careful here. The graph starts at origin. Please add this part in your graph. It should start at origin, and it should have that particular shape where you have, in this case, here you have the largest amount, the largest proportion of particles that have energy less than the activation energy. So this activation energy, this amount of energy, this amount of kinetic energy that represents the activation energy, this is going to be the same for the similar reaction. Be careful, the curve here that you're drawing, the curve is not symmetrical. If ever you draw a curve that looks like this, you are going to be marked down. It is very important to maintain the shape of the curve in a Maxwell-Boltzmann distribution curve. Any factor that is going to increase the number of successful collisions will eventually lead to an increase in the rate of reaction. There's two categories of factors that will affect the rate of reaction. One category is factors that affect the rate of collision. So, for example, you have concentration, which applies for aqueous substances, and pressure, which applies for gaseous substances. So if you increase concentration or you increase pressure, you are going to increase the number of particles per unit area. So the more particles you have per unit area, the more collisions you're going to have, the more successful collisions you're going to have. So rate of reaction will increase. Another factor is surface area. So the larger the surface area, the larger the chance of having successful collisions. So these are two factors that relate to the collision rate. Now, factors that will affect the proportion of particles with the required activation energy are temperature and catalyst. Now, because these two affect the proportion of particles with activation energy, these two factors will be studied in relation to the Boltzmann distribution curve. And these two will relate to frequency of collisions.